All right, we will be moving on to a sponsor presentation. So we would like to thank our sponsors, and let's everyone give our attention to James Coomer from DDN. He will be discussing optimizations for AI in the EXAScaler file system. James is Senior Vice President of Products at Data Direct Networks and is responsible for the technology direction, roadmap, and performance analysis of DDN solutions. One of his main tasks is engaging with and understanding the issues of organizations that are exploring the extremes of I/O performance across the range of industries, from life sciences through to finance, with use cases from cloud, enterprise big data, and on through to AI and HPC. James, go ahead and take it away.
Great, thanks very much. Thanks, Ross, for your previous presentation. That was interesting. Let me share my screen. I'll do that successfully. So if you can confirm you can see it and I'm not upside down or anything, that'd be good. We're looking good?
Looks good.
Great, thanks. So yes, your commercial break from DDN. I want to talk to a wonderful audience here about the progress we've made in taking Lustre, or at least DDN's version of Lustre, which we call EXAScaler, and introducing it into this fairly rapidly emerging and growing market for AI. We have talked about this for the past couple of years, and so really this is a catch-up. It's kind of a walk through a bunch of the stuff we've done, not only around performance, but around feature sets and ecosystem integration, and being a better fit with that new customer base, which is of course very interesting to us. So who is us? Us as DDN, I guess people generally know. So here's the one slide to remind you who we are. I run product at DDN, which is now 7 different storage products. We've had various acquisitions, which you may not know about. So we've acquired Tintry's VM store, we acquired IntelliFlash product, we acquired Nexenta. So quite a lot of activity in the past few years, which means that now we are a 10,000 customer company with 1,000 employees, over 150 patents, and we've been now around for actually 22 years, and we're the largest privately held storage company. So things have changed quite a lot at DDN, I guess, and we have a broad array of storage products, and I'll talk just about EXAScaler here and the ancillary pieces around that. So the customer base is broad and prestigious today. We do have customers in core enterprise, typically using Tintry and Nexenta and IntelliFlash. Those are companies in telcos, in small and medium-sized businesses, as well as the kind of Fortune 100 businesses that you're very familiar with. We also have a sort of class of customer called enterprise at scale, which tends to be like oil and gas and large-scale pharma, life sciences, chemicals, that kind of thing, who do HPC-like things, but are really commercial enterprises. And then, of course, there's the customers you know very well, government and academia customers, who we've been dealing with for a very long time. And then finally, there's a sort of a bunch of customers moving into AI and analytics in a very serious way, as opposed to mixing up that with HPC. And what do we typically ship? Well, it's something like this. I'm not really going to talk much about platforms, but I thought it might be nice for you to see the shiny bezels before we move forward and talk about the software changes. The current range does look like this. So this is just the EXAScaler range. And this varies from an all NVMe platform on the left, often used for high performance metadata, through to the system on the right, which is typically used for very large scale systems, not exclusively though. The differentiation of the ES18KX there is that it can manage a lot of drives. And that means that we can build very large simple systems and keep them reasonably simple. So if you want multiple hundreds of petabytes, then we can do that with just a handful of these ES18KX, with each one serving about 20 petabytes. So it's kind of an interesting characteristic. Our underlying firmware called SFAOS is very good at managing extremely large quantities of drives. That's good from an administrator point of view, because you have less servers, less processors, less memory, less DIMMs, less things to manage, less operating systems to manage in the systems. And when the data volumes get extremely high, that's a good thing. Kind of a first order approach to simplifying at scale storage. There will be changes here, by the way. So if people want to hear about the roadmap, they can come and talk to me. Won't go into that here. And one of the pieces of magic we've done, which has been quite successful for the past few years, is embedding all this EXAScaler, Lustre software, and ancillary pieces and our SFAOS, our firmware, inside these appliances. So that's really been a journey of almost maybe 10 years. We're now in our 4th generation of embedded systems. And of course, it gets much easier as we go on because there's loads more horsepower available, lots more memory. So this system you're seeing here, I'll talk a bit about it. It's branded the AI400X. It really is EXAScaler, and it's dual controller, HA, etc. But it's also running essentially virtual machines which run the EXAScaler software. So EXAScaler and SFAOS are working in tandem here. And over the years, they've been pretty tightly integrated. So things like end-to-end data integrity is performed here. So the Lustre checksums are passed through to SFAOS. So we can continue the path of integrity further down towards the disks. So that data integrity checking really happens at every stage from the client down to drives here. And of course, in performance, matching up block sizes and stuff, we've done a lot of work there. And a lot of work in making the cache management sympathetic to the Lustre style workloads. And the best thing is this is a 2U appliance and customers plug it in. There's no cables needed apart from the ones that go in the back of the box, no extraneous servers and stuff like that. So we can make the approach pretty simple. I am weaving around a bit, by the way, to try and get some fun things in. This was just some benchmarks we did last year. And to start with, we weren't doing super well on this benchmark. So a lot of the client work that's been done by DDN this year has been done in removing some of the latency associated with these analytics type workloads. No time to go into detail, but we've probably improved these numbers, which are now kind of just about the winning numbers. It's difficult to say winning when there's talking about a benchmark, which has many different micro benchmarks. But this is the Stack benchmark. They're a company that builds test suites to prove the performance of systems in the face of financial workloads. So there's various different micro benchmarks, and we really worked hard to get the latency reduction in there. And I'm sure if we chat around in the, whatever we call it, the discussion floor, I don't know what it was called, then we can talk a little bit about what we did there to reduce those latencies and get these nice numbers you see here. One other fun thing, we have introduced EXAScaler into the 3 biggest public clouds out there. So AWS, GCP, and Azure all run EXAScaler with DDN support behind it. So that means that customers who are interested in cloud and they want to have a good cloud strategy going forward, but don't really want to commit on day one to one particular cloud, do have a bit of choice with DDN. We work particularly well with GCP, Google guys, and have lots of interactions with them and with Azure. So there's a great deal of choice here, probably for the first time ever to have a very large, fast parallel file system available on all these 3 clouds. And we're looking at more as well. Here's a little example of the Google system. We ran that with the Google team probably maybe a year ago, even 6 months ago. So you can see here, you scale up to around 40 OSSs, but each OSS is a relatively small instance compared to a server. And here we're getting around 50 gigabytes a second with a 400 terabyte file system. But the really nice thing is that this literally takes about 5 clicks and 5 minutes to build. So the templates are there, you go click, 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 and you've got an EXAScaler file system. We made that process pretty consistent across the 3 cloud products. One thing we also did quite recently was support the CSI driver and update that. We leveraged some work from our Next Center group and brought that in. So you'll see that sitting there. If you try and download CSI driver for EXAScaler, you'll see it right there. And that's really, by the way, that ties into this AI thing. Typically, for the new AI customers, they are using containers. NVIDIA provides a large container repository for these AI frameworks, and that tends to be the mode operandi for at least newcomers to the AI market. I want to spend just a few minutes quickly swinging through in DDN Insight. There are many, many products in the world called DDN, called Insight, so ours is definitely called DDN Insight. Here, what you're seeing is an aggregator. So if you have multiple file systems, this is one view that gives you a view across many, many different file systems, aggregating that stuff. We've also brought a new look and feel into the dashboard. So new graphing technologies, much faster, much cleaner, and some very nice new views. So super simple, very nice to navigate around things like OSS and OST performance, digging into hard drives, also managing the underlying SFA appliances, managing and providing alerts for data capacity and inode capacity. And then also kind of extra special fun is the Workload Analyzer. So this is based on job stats. And job stats, as you know, is the way we pack in job ID and other information into the RPC and collect that on the server side, and then pass it through so we can present it back to the administrators to find out who's trashing the file system with a terrible workload. So here you can see a very nice implementation of that. We will order the consumers of your system by throughput, IOPS, and metadata. You can dig down and look at the time series view of that job. And you can also see the shape of the IO patterns hitting your file system at any point in time, and look back in history to see if there's any rogue things going out there, people doing bad stuff to your file system. We've got a few screenshots in there. So also for this AI customer base, we have introduced new features. So broad protocol support, NFS, SMB, and S3 in scale-out namespaces. We've done a lot of work in optimizing for DGXs, for NVIDIA's DGX A100. The internal architecture is a NUMA architecture based on AMD with many interfaces. So it takes quite a lot of work to really optimize that system so it works well out of the box without requiring our customers to bend over backwards to optimize and tune it themselves. So we've done quite a lot of work with multi-rail to automatically detect what's going on and manage the rails in a sensible way from start to finish from the DGX, which actually has up to 10, but really we don't use all 10, generally speaking, of these interfaces. Now a DDN AI400X has 4 such ConnectX-6 interfaces. So a lot of networks going on there. So multi-rails really helped. The results, by the way, we haven't got a lot of time to talk about it, but the results of that tests are all published in a reference architecture documents, which is a combination of ourselves and NVIDIA producing those. You can see here from a single AI400X, we're pushing, actually, in truth, we push 50 gigabytes a second. It's gone up a little bit from here, but here we see 47 gigabytes a second into a single system. When
hey, James, we've got 2 minutes, sorry.
Sure, yeah, I'm rushing towards the end, it's okay. Here we're looking at quite a fun number, so 178 gigabytes a second. That is using 4 of our AI400Xs, and that's all going into a single DGX A100. So it's kind of cool, very incredible amount of throughput going into one machine through 8 of these InfiniBand interfaces, and the write performance is also not bad. So the success has been good, and I think everybody will be pleased to know that Lustre, especially in the form of EXAScaler, is being used for drug discovery, particularly for COVID research. Recursion's a great customer of ours. Lots of big superpods, which I won't talk about. Superpods are NVIDIA's largest systems, and it's been a very successful and rewarding relationship for ourselves to work with NVIDIA. I'm just skipping through a number of examples here. In Sweden, St. Jude's, in Florida, the world's largest academic supercomputer, great customers with a fantastic new system. And in Selene, which is the largest commercial AI supercomputer in the world, pretty big, and this is where our reference architecture documents came from. So I will encourage you to go and read that stuff. The reference architectures are available. Here's a little screenshot of us doing about 500 gigabytes a second into that system to 128 of those DGXs, by far the largest scale that's been measured out there and published in the form of these documents. Okay, that was it. Quite a quick run through. I hope nobody had a fit to the speed I was moving through those slides. So that was our kind of a real subset of what we've done with EXAScaler to make it appeal and be successful in this AI work, in this AI world. And that has been very successful. We will see pretty much all the superpods out there are running DDN's EXAScaler in the form of our A3i systems, which have been packaged and optimized and with additional features to suit those markets. Thanks very much.
Yeah, thank you so much, James. Appreciate the presentation and the sponsorship. Looks like there was only one question. Someone would like for you to clarify the asterisks on AWS as a cloud offering of DDN.
Oh, yes. I mean, that doesn't need to be an asterisk anymore. I think that was an asterisk before we'd updated the offering to EXAScaler branding, which was done 2 months ago. So no asterisks needed.
Fantastic. Thank you very much. Appreciate it.